All right. Welcome, everybody. Thank you for joining. Today, we're on day 2 of our 3-day Learn Java Live seminar webinar. And today, on day 2, we're going to discuss the principles of object-oriented programming. And I'll do a quick intro here, just in case you weren't with us yesterday. My name's Ryan. I'm a co-founder here of Coding Nomads. I've been a Java engineer for 12 plus years, and I've been teaching Java for over 5 years. And we have been running these courses at Coding Nomads both in person and online for the last 4 years. So in this training, we're going to talk about what is object-oriented programming. We're going to discuss encapsulation, inheritance, and polymorphism. We're going to talk about why OOP, which is what we call object-oriented programming, to be short, OOP, why it's so useful, and some common use cases. If you weren't with us here yesterday was introduction to Java, and we learned about variables, data types, operators, if-else statements, the for loop, the while loop, and the do while loop, as well as arrays. So we covered a good bit of information there yesterday. And today's discussion is going to be a bit more intermediate, right? So it's not a direct follow-up on yesterday's, because today we're going to go straight into object-oriented programming, which kind of takes you into that intermediate zone of developing with Java. And tomorrow in day 3, we're going to jump even further, and we're going to build out some custom data structures like linked lists, hash maps, queues, and stacks, kind of designed to get you thinking in that computer science interview-ready mindset. So what is object-oriented programming? This is a big question, and it has many answers. But at the end of the day, OOP is a paradigm, a programming paradigm. And a paradigm is not necessarily a syntax, any specific technology that we use, right? A programming paradigm is just the way that we write our code, the way that we structure our code on the page, right? And in the application. And object-oriented programming, it organizes our code around data, right? So, and we put that data inside a class, and then we can create objects of that class. A class is like a blueprint for objects. It's literally almost an exact analogy, like the way we use a blueprint to create houses. You could have a single blueprint, and you could create 7 houses from it. A class is the same way. The class is the blueprint, and we can create 7 objects from that. And the same thing with building houses. You can have that blueprint, but one house can be white with blue trim. Another house can be, off-white with red trim, right? They can have these unique characteristics about that house. One of them can have an extra bedroom, and one of them can have a loft. One of them can have, a 2-car garage, and one of them can have a 1-car garage, and one of them, you can modify them and tweak them a bit. They can have their own distinct characteristics, but they're also object from that same blueprint. In this case, house, right? If we were creating, any kind of application that dealt with architecture or houses. The really nice thing about object-oriented programming, and what I note here in the 3rd bullet, is that it allows us to model the world around us in a very intuitive way. And this is what's really useful about object-oriented programming, because we can look around. Like here, I'm looking at a bookshelf. I see books. I see a laptop. I see a little cutout of a whale, right? These are all immediately I can think of how I would make Java classes that would represent those elements, such as a book or a computer or a little whale cutout thing, right? So whether it's whether we're going all the way down to the microorganism level, or the idea of a cell, or even atoms, electrons, neutrons, protons, etc., we can even model that, because if we can imagine it, we can write a class that describes it. And then from that class, we can make many, 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 many objects, right? And so all the way down to, neutrons, protons, electrons, all the way up to solar systems, planets, stars, galaxies, supernova, and anything in between. If we can imagine it and we can describe it in our heads, we can model it using object-oriented programming. And that makes it really easy, and well, easy is a loose term, but it makes it possible for us to think about any situation and start to model the way that we would write the application to manage that situation. So for instance, let's say that you are creating software for a restaurant, right? Immediately, like, that point of sale kind of touch screen system that you see a lot of restaurants, where they can put in an order for table 4, and they want these drinks and these entrees, etc. Immediately in my mind, if I was going to write software for that system, I would start to model it out in objects, right? So I've got the idea of menu items, I've got entrees, I've got appetizers, I've got cocktails, I've got non-alcoholic drinks, I've got tables, I've got customers, I've got, you know, servers and bartenders and kitchen staff, you know, and I can immediately kind of start breaking down all the elements that might be needed to be involved in this application. And then I can create a class that describes each one of those. And then I can create objects from them. So from a single table class, right, I could create 10 tables. I could give them each a number. And then I could put customers at those tables. And then each customer, I can give to them specific menu items. And this will make more sense. But just to kind of spell out kind of what it is that object-oriented programming helps us to do. Another, you know, other programming paradigms that go alongside object-oriented programming would be things like functional programming, procedural programming, and imperative programming. And one just small quick note here is that a lot of times when you're writing code, you're actually using several different paradigms at once, right? And when we talk about this is functional programming, or this is procedural programming, or this is object-oriented programming, what we're really talking about is which one is most dominant in that application. So this can be a little bit confusing, but they're just ideas, right, about how we write our code and how we structure our code to help us, you know, create complex applications. And just as a quick difference, functional programming, instead of organizing its code around data, like objects, it organizes its code around functions, right? So we'll just create a bunch of functions that complete a specific task, right? So this functional is very, very common in JavaScript, right? So for instance, when somebody clicks on a button on the screen, we'll add an event listener to that behind the scenes, and then we'll call a number of functions to do a number of things, right? It's almost as simple as that. It's just we don't think about you creating and manipulating data objects. We just think about calling functions, and we pass each function the data that it needs to do what it needs to do, and then that's it, right? It's done. Procedural programming, you can think of, it's just a list of steps. It's a procedure. Step 1, do this. Step 2, do this. Step 3, do this, right? And imperative and procedural can be kind of difficult to distinguish the two, but imperative is kind of like commands. You're basically going off a list of commands, similar in a way to procedural, but the one thing to keep in mind with Java is that Java is built in an object-oriented language. It's meant to be used as an object-oriented language. But half the time, or when we're writing our Java code, a lot of the code that we're writing is also procedural and imperative, right? Because we're just kind of saying, now go do this, now go do that, now go do this. And we're not necessarily always dealing with the idea of an object. So just to throw that out there. So there are 3 primary tenets, technically 4. I like to just say 3 because abstraction and polymorphism, in my mind, kind of blend together. But there's the 4 primary tenets of object-oriented programming are encapsulation, inheritance, polymorphism, and abstraction. So let's take a look quickly. Before we jump into the code, we're just going to chat about these here. So encapsulation is, and all of these words kind of have, I think are a little more intimidating than they necessarily need to be. Encapsulation just means that all the data and methods, aka functions, that will act on that data or operate on that data or even access that data are encapsulated within one class, or a given class. So for instance, let's say that I have this idea of a box like I have here on the left. All the variables, which you can see on the orange panel there, int height, int width, int depth, these are the variables that will describe this box. And here I've set them all to 10, but in a class, you would not, like in the class definition, you would not set these to 10. It would just be int height, int width, int depth. And these are the variables that define this box. And then over here on the blue side, we've got the methods that will act on or operate on that data, such as get height, get width, set width, get depth, set depth, right? And down below, you can kind of, and you know, this isn't fully fleshed out. I don't have a constructor in here, which is what these 3 arguments are for. But here is an example of how we could create multiple objects from this box class, right? So the file is called box.java. Once it's compiled, it'll be a class file. It's also called the box class, right? So here I'm creating 3 new objects of this box class. The first one is called B1, and it's got the dimensions of 5, 5, and 5. The second one's called B2. It's got the dimensions of 7, 7, and 7. And the third one is B3 with the dimensions of 10, 10, and 10, right? So all the data about this box, its width, its height, and its depth, are inside the box class, right? Inside the box.java file, as well as all the methods that may act on that data in any way, right? Whether we're getting that data, setting that data, modifying that data, or doing anything, pardon me, anything related to a box, it's going to be inside that box.java file, inside that box class, right? And a really simple way to think about this too is on that second bullet point, I say all data and methods related to a cat will be in the cat class, and all data and methods related to a dog will be in the dog class, right? So there's no way that a cat will ever have the method bark, right? And there's no way a dog will ever have the method meow, right? Because those are going to be in their respective classes. So anytime you need to ever do anything related to a dog, you're going to go look in that dog class or in that dog object. And that's it. So that's the idea of encapsulation, where we encapsulate all data and methods that act on that data into the appropriate class. The next primary tenet of object-oriented programming is inheritance. And this is actually quite intuitive. The same way that you already understand inheritance from your family, or the way inheritance works in the natural world, we can do the same thing in Java with classes. So for instance, here we've got like a nice little inheritance hierarchy with food, veggies, fruit. Let's go down the fruit line for a second. So food can be a nice generic class, and this, just so you know, this often builds up over time as you're writing your code. You kind of realize like, oh, I'm writing two classes that are very similar. I'm going to make a parent class, right? So let's actually start from the bottom. Let's say that the first class I write in my application is a red apple, and I put all these attributes in it like caloric value, flavor, number of seeds, color, all of these things that describe a red apple. And then a little bit later, I realized I also need a green apple class. And so then I start to create that green apple class, and it's got a bunch, almost 99% the same attributes as the red apple class. There's just a few things that make it different. But so I basically got these two matching classes that both have caloric value, number of seeds, flavor, color, etc. And in coding, one of the biggest mistakes that we can make is repeating ourselves in multiple places. We don't like to write the same code twice, right? And DRY, don't repeat yourself, is one of the strongest kind of rules in programming. And if I've got two classes, red apple and green apple, and they're 99% identical, because red apples and green apples in the scheme of the universe are very, very similar, right? So what I can do in that case is I can create a parent class called apple, and I can put all the traits, meaning the variables and the methods that are similar between the two, the red apple and the green apple, I'll put all those similar traits up in the apple class. And then the red apple and the green apple, all they have to do and all they're responsible for is indicating what makes them unique from, like, for instance, what makes the red apple a red apple versus the green apple. And all the things that make them both an apple will be in that apple class, right? So we can take this a step further, and let's say the next day I realize that I also need to write an orange class, right? An orange is not an apple, but it's got a lot of the same attributes. It's got seeds, it's got a skin, it's sour, all the things that make an orange and an apple basically the same. So I start to see that my apple class and my orange class are very, very similar, and they share a lot of attributes, right? So when I see that, I'm going to say, you know what? I'm going to create a parent class here called fruit. And all of the attributes that an apple and an orange share, all the variables that either of them have and methods that either of them have that they share, I'll put in the fruit class, right? And that fruit class is called a parent class, right? And these subclasses are called subclasses. Just to finish out this analogy, let's say that the next day I'm writing something about, I'm creating a lettuce class, right? Or a celery class or some kind of vegetable. And I realize that this vegetable class has a lot of the same stuff as the fruit class. Like I've still got caloric value. I've still got all of these attributes that veggies and fruit, vegetables and fruit share, right? And so again, instead of having two classes that have almost identical, and that it's not necessarily identical, but a number of shared attributes, where in the veggies class, I've got an int caloric value, and in the fruit class, I've got an int caloric value. That's bad. We don't like that. So what I'm going to do is I'm going to create a parent class called food, and that int caloric value and all the other shared attributes between veggies and fruit are going to go up there in food, right? And so this seems a little bit confusing at first, maybe when we're modeling it and when we're trying to figure out what does my inheritance hierarchy look like. But keep in mind that, again, kind of like we described it here, oftentimes it shows itself over time as you're developing it, right? You don't necessarily start with the food class and work your way down. In reality, when you're actually coding, it's more like you're starting from the red apple or the lettuce class and working your way up, and you start to see that you're creating classes that have shared attributes. And that's the telltale sign that you should just create a parent class and have both of those classes extend the parent class. And when a subclass extends the parent class, like, so for instance, when apple extends fruit and fruit extends food, Apple has direct access to all the variables and methods that are public and protected, just to be clear, in the fruit class, as well as the food class above it. The apple is effectively a fruit, and it is effectively a food. So any of the attributes, variables, methods that are in either the fruit class or the food class are accessible directly to the apple class, as though those variables or attributes exist in the apple class, right? An apple is a fruit, an apple is a food, and so an apple has direct access to all the public and protected attributes in those classes. This really helps over time in a really complex application, because obviously, as you can imagine, redundant code. Imagine if you were creating a software for some kind of let's say grocery store. And in the vegetable aisle alone, you're going to have the hundreds of classes and a lot, and I call it the vegetable aisle, but it's got the fruits and it's got, other things in there too. You're going to have hundreds and hundreds of classes that are basically redundant with some slight differences, right? And that gets really tricky to maintain. It becomes really buggy. When it's time to update something, you end up having to update something in lots and lots of different places. And so what we like to do is basically compartmentalize our code and make it reusable, right? And make it as simple as possible. So any single fruit that I create, any single fruit class, any single, let's say it's peach, right? I can create a peach class, and I can have that peach class extend fruit. And now the only thing that I have to do inside that peach class is define what makes a peach, right? So I might do something about the pit or something like that. So inheritance is a really important one. It's probably the encapsulation, inheritance, and polymorphism. Those three things, and we're going to talk about polymorphism in just a moment. If you're using those three things, it's just definitely you're using object-oriented programming. So let's talk about polymorphism. This one can be the trickiest one, I think, for people to understand at first. And polymorphism just means many forms or takes many shapes, right? And in this little diagram here I have on the left, kind of the most famous analogy for polymorphism is the idea of a steering wheel in a car. Just so you know, this also is the same analogy I would use to describe abstraction, right? So it doesn't matter what kind of car you're driving, whether it's a sports car or a truck or a tractor or a Tesla or a go-kart or whatever. If it's a car, you know that there's going to be this steering wheel, right? And you know how to use it. But behind the scenes, like once that steering wheel goes into the dashboard, what happens behind there is different in every single car, right? In the go-kart, it goes straight to this little shaft that turns the wheels. In the Tesla, it does some kind of crazy electric stuff. In the tractor, it does something else. And in your sports car, it does something else. It's the same steering wheel, but it takes many forms behind the scenes. And the details of what it does behind the scenes are abstracted away from the end user, right? So that's where kind of polymorphism and abstraction, I'm sure there's a much better somebody that could make a good argument as to how to describe them uniquely. In my mind, I kind of just put them together because we have this idea of a steering wheel, and we'll look at this when we get into the code, but we can create all of these different classes, right? All of these different vehicle style classes, and we can give them all a steering wheel, right? And when somebody calls that steering wheel method or calls the turn right or turn left method, it'll be the same exact method that you're calling against any kind of vehicle object. You could say tractor.turnRight, fighterjet.turnRight, go-kart.turnRight, Tesla.turnRight, whatever. No matter if it's a vehicle of any kind, you know that you have the ability to turn right on it. And so it looks like a single method. It looks like a single behavior that you can do on any single object that's of some kind of vehicle type. But what's happening behind the scenes is actually very distinct and unique between each one, right? So many forms. It's that turn right method. It looks like a single method, but it's actually in this little diagram, 8 different, 8 methods, or AKA functions that are being called behind the scenes that give it many different forms, right? Also, the details of what's happening behind the scenes, the actual mechanism for how the tractor's turning right versus how the jet's turning right versus how the go-kart's turning right, that the details of that process being hidden from the end user is what we call abstraction. So let's jump in and actually look at some code here, yeah? Just let me switch over. So I'm going to stick with this idea of a truck, and I'm just going to kind of step into it here. So I'm going to create a controller class that we can just use to kind of demo our code here. I'm going to put a main method in here. And if you're just getting started in Java, just a quick side note, the main method is basically the front door to your application. It's what the JVM will look for to run when you start your application. It's going to look for this public static void main method, and whatever it finds in there is what it's going to execute. So I've got this POJO. This is called a POJO, a plain old Java object. And a POJO is just a class definition. In this case, it's a definition of a truck. And a truck, in my opinion, has a number of doors, a horsepower, a current speed, a bed length, and these are all ints, and then a Boolean has camper shell, right? Some trucks have that shell above the camper, above the truck bed, and some don't. With this class, this is now a blueprint, right? I haven't actually set any data on this. This is just a blueprint. With this class, I can now go create objects. So for instance, I can say truck T1 equals new truck. And what I've just done here is I've created an object of type truck. And if you were with us yesterday, or if you've been studying Java already, you'll know that there's 2 primary types of data in Java programming. There's primitive data types, which is what we covered yesterday, Boolean, byte, short, int, long, float, double, char. I think I got them all. Those are primitive data types, right? They can be represented by a single string of zeros and ones, a single string of bits in memory, like the number 74 or 74 billion. It can be represented by a single string of bits in memory. The other type of data in Java is called object data type. And we've, there's a lot of object data types that are built in to Java. String is kind of the most common one that we'll use. But we can also define all of our own object data types. For instance, I've just defined this truck data type. And as you can imagine, a truck, once this is filled out, it can't be represented by a single string of bits in memory. It's actually represented by several different areas in memory, and collectively, that is known as an object. So in my controller, I can create, T1. I'll say T1 dot horsepower equal, what's the truck's horsepower these days? I don't even know. 300. T1 dot bed length. Let's go with inches. How about 50 inches? T1 dot current speed. Let's say that it's not moving anywhere right now. It's currently going 0 miles per hour or kilometers per hour. And let's go ahead and say that it does have a nice camper shell. Anything else on there? Current speed, bed length, horsepower, num doors. Let's just make this a nice simple 2-door truck, right? Now I've created this object of type T1, and I've set these instance variables. So in the truck, just so you know, these are called instance variables. And what that means is that each object gets their own copy of these variables, right? So in a moment, I'm going to create truck T2, and T2 can have its own number of doors. It can have its own horsepower. It can have its own current speed, bed length, camper shell, etc. As a quick, just since we're right here and it makes it a bit easier, what you'll often see here are constructors. So a constructor is basically there we go. A constructor is kind of like a method that will be called when you use the new keyword. So for instance, when I say truck equals new truck, And I can pass in these attributes, and basically the number of doors that I pass in, as I'll show you in a moment, will be set to the this.numDoors, meaning the instance variable numDoors in this class. If I do this, if I create this constructor right here, and again, this constructor will be called when I use the new keyword, when I'm creating an object of this class. Since I've created this constructor, this old way won't work anymore, right? Because you can see that I'm not passing in all the required variables right here. So what I'm going to do just to keep this working is, and you can overload the constructor, I'm going to create multiple constructors, and I'm going to have one that's default, meaning it takes nothing, so that this will still work. And then I have one, what I call fully qualified constructor here, that takes all the arguments. So let's go ahead and demonstrate that second one. So I'm going to say truck t2 equals new. There's that new keyword, which means that the constructor is being called. And then in here, it takes the number of doors, horsepower, current speed. Let's start there. So let's say that this is a 4-door. Horsepower, let's just make this a bigger truck. Last one was 300. Let's go with 500. Current speed, let's say that this one is currently driving down a nice rural street at 25 miles per hour. And bed length, camper shell. So let's say the bed length, it's bigger truck. Let's go with 75. And this is a work truck that does not have a camper shell. And I'm just going to put this on multiple lines so I can leave the text nice and big, but all on the screen here. So now I've created two objects of this truck class. One's called T1, and I've just set the variables directly like this. And the other's called T2, and I've used the qualified constructor to pass in those variables to the constructor so that when the object is created, all of these variables will be set right then. I won't have to set them like this, right? One more thing I'm going to do here just to demonstrate this, a very, very common method is a toString method. And just so you know, to get this little generate method, it's different kind of on everyone's computer, but I'm holding down Control and hitting Enter, and that pops up this little menu. If you're on a Mac, it might be Command or Option and Enter will pull up this little menu, but it's super useful. I'm going to make a toString method, and I'm going to include all the attributes. And so when I call this method, it's going to construct this string. Notice that it's just a string that it's creating, and it's going to basically construct it for me, and then it's going to return it. So over here in my controller, I can basically say sout system.out.println t1.toString, and then I'm going to do the same thing for t2.toString. And let's see what happens when I run this. There we go. Okay, so it printed out two trucks. The first one has 2 doors. It's got a horsepower of 300. Its current speed is 0. Its bed length is 50, and it does have a camper shell. The second one has 4 doors, 500 horsepower, a current speed of 25, and a bed length of 75. And it basically stays that way, right? So this might be a little oversimplified, but for instance, let's just say that I want to, I can say, for instance, my truck has, plus I'll go with the t1.numDoors. Right, and this, what I'm doing right here is just called concatenating. I'm concatenating a couple of values together to make a single string. So when I run this, it's going to say my truck has 2 doors. If that's what's going to print out. And what we're dealing with here is an object of type truck, right? And the data that defines that truck, right, is all inside the truck class with these instance variables, and the objects that act on that data, which we haven't quite messed with yet, but like start, stop, accelerate, decelerate, all the things I might do on a truck, they're also inside that truck class, right? So here I can say my truck has t1.numDoors doors, and I could then just very quickly say your truck has plus t2.get .numDoors. And as you can see, this becomes really useful really quickly, because if we're at an auto, let's say that we're creating an application for an auto dealership, right? I can just have this idea of these various types of cars, and I can actually I can create an object for each car in the lot, for instance, if I wanted to, and I can actually assign data types, data values to those objects that accurately describe all the cars in the lot, right? Or the fact that my car has 2 doors and your truck has 4 doors, right? And we can create thousands and thousands and thousands of these objects if we want to. One thing to note here is that we're not always kind of manually just creating the objects and setting all the variables like we are right here. Just something to keep in mind, because it's a common confusion when people are first getting started. Oftentimes, let's say that we have to create 1,000 objects of this truck class. Usually I'm going to be getting that data, those 1,000, the data that represents or describes those 1,000 trucks. I'm going to be getting that data from a database or from a RESTful API or from a CSV file that we're reading in, right? So it's not like you're going to have to write this kind of stuff 1,000 times over and like literally manually describe each truck or car in the lot, right? All that data will probably already be in a database, and this is more complex, but we would read all that data out of a database, and we would map that data onto an array list, for instance, of Java objects, in this case, truck or car, right? So just so you know, you're not going to have to manually kind of always create these objects like that. I'm just doing it right here for demonstrative purposes, right? So this is kind of the first idea of understanding what a class is. So I've got this class truck, and I can make objects from this class, such as T1 and T2, right? That's the variable name for these objects. The T1 and T2 both get their own copy of all these instance methods, meaning T1 can have, one truck can have 2 doors, another truck can have 3 doors, another truck can have 4 doors. I don't know that any trucks have 1 door, maybe a tractor might be a truck that has 1 door. But they all get their own copy of every one of those. And so they become like these unique, distinct objects that are represented in memory, and we can interact with them really intuitively, like we did here. My truck has T1.num doors. Your truck has T2.num doors. Like, give me the number of doors on that object T2 of type truck, right? And oftentimes it really is pretty intuitive and self-explanatory once you start to get comfortable with it, right? So just to demonstrate, we can also call methods on what are called instance methods, and I'm just going to stay away from the idea of static versus non-static in this discussion. It's really interesting, but let's punt on that for right now. These are called instance methods. So non-instance would mean that you would see the word static in there. And like I said, I'm going to just punt on that for right now. It can add some confusion. Once you understand all of this, the static non-static thing is really just like it takes a half an hour of like good hard thought and a couple good demonstrations to kind of understand the difference between static methods and static variables, and non-static methods and non-static variables, aka instance methods and instance variables. But these are instance methods. And what that means, since there's no static keyword there, is that when I call start or stop or accelerate or decelerate on a given object, it's only going to operate on that object. So for instance, I can say T1.start, T1.accelerate, T1.decelerate, T1.stop, right? And then I could do the same thing on T2. I could say T2.start. And now when I run this, we're just going to see in these methods, all I did was some system.print lines like starting truck, stopping truck, starting truck, starting truck. And here we don't have like a name or anything like that, but you'll basically just see like truck starting, truck accelerating, truck decelerating. And when I say start, accelerate, decelerate, or stop on that T1 object, it's only acting on that T1 object. So starting truck. Oh wait, these all just say starting truck, accelerating. Decelerating truck. So let's try that again. So here we can see starting truck, accelerating truck, decelerating truck, stopping truck. This all came from T1, my truck. And then starting truck here, it's a little, not super obvious, but this came from T2, right? So on each one of these objects, I can access its instance variables, and I can call these instance methods to modify that, right? So I could, for instance, let's say real quick, last thing I'm going to do here is I'm going to create a setter method. A setter method just means I want to set one of these variables. Let's say let's say has camper shell. And that's going to take in a Boolean and say this dot camper shell has camper shell. Typically, these variables are going to be private, just so you know. They don't always have to be. And the way you're going to access them is use public, what are called getter and setter methods. This is an example of a setter method, and the corresponding getter method for there would be just real simple. Public Boolean is has camper shell, and it'll return the Boolean has camper shell. Over here in my T2, initially when we created it, we said it does not have a camper shell, but now after this, I'm going to say T2 dot, what is it? Has camper shell, or let's use the setter. T2 dot set has camper shell, true. So let's just say I've had my truck, or you've had your truck for a while, a year or two later, you decide that you want to add a camper shell to it. Great, you can do that. And now I can say, let's just say sout. Like, how about true, false? Your truck has a camper shell. And let's say T2.get T2.has camper shell. But let's use the getter method there. Get is has. There, that's what it was. And again, I'll put this on the next line so we can just read it. If I take this line right here and I put it above where I set the camper shell to true, the first time it's going to print out false, and the second time it's going to print out true because I've modified that object. I've called that set has camper shell on that T2 object, and I've set it to true. So the first time it was false, and the second time it was true, right? And just on that T2 object, right? So just try to illustrate here that we have this idea of this truck object. We've got two of them, and we can modify them as we see fit, and they'll stay unique and they'll stay distinct. And now I can just kind of intuitively and logically start managing these truck objects, right? So let's take this a step further, right? Let's say that we've got this truck class, and let's say that later in the day, or 2 days later, all of a sudden I realize I need a sedan class. So let's create a sedan class. And I know that a sedan has an int num doors. I know that it has an int current speed. I know that you could do the sedans and trucks have lots of different things. Something that a sedan has is a int trunk size. What else do we put in the truck? We have bed length, has camper shell, horsepower. A sedan has a horsepower as well, so let's say int horsepower. And a sedan has the ability to start, stop, accelerate, and decelerate. So you're already probably seeing the problem here, right? Or not necessarily the problem, but the inefficiency or the area for optimization. This sedan class and this truck class, let me make them about the same size. One of them's got a constructor, right? And let's just pretend for a second that these are gone. If you go back and forth between these two classes, you see that they're very, very, very similar, right? Because a truck and a sedan do have a lot of very similar attributes, right? They both have a number of doors, a horsepower, a current speed, and the ability to start, stop, accelerate, and decelerate. So as you're probably already assuming, this is a perfect opportunity to create a parent class. So what I'm going to do here is create a parent class, and I'm going to call this vehicle, because a truck and a sedan are both vehicles. And what I'm going to do is I'm going to pull all the shared attributes from the vehicle and sedan class. I'm going to pull them into this from the truck and the sedan class. I'm going to pull them into this vehicle class. And this truck class is now going to extends vehicle. I'm also going to put, so we're going to go a couple rounds on this, but I'm going to put these methods also in the vehicle class. But instead of truck or sedan, it's going to say starting and stopping vehicle. And I'm just going to comment that out for right now. We're actually going to come back and mess with this a bit in a second. But now you can see that the truck, it extends vehicle. So that means it's going to have direct access to all of these variables and methods. And all it has to do is define what makes it a truck, right? It's got a bed length and a Boolean as to whether or not it's got a camper shell. Obviously out there in the real world, there's going to be more than, two variables that make a truck, but you don't need to go over the top, right? And in fact, we actually want to keep our classes as simple as possible, right? So the same thing is going to happen here in the sedan. I'm going to say sedan extends vehicle. And now basically, this was trunk size or the boot. I'm going to comment those out as well. A sedan now just all it has to do is define what makes it unique, right? So over here in the in the controller, you'll see that we can still say T1.start, T1.accelerate, T1.decelerate, T1.stop, T1.start, right? These methods, they don't exist in the truck class. They're gone. I commented them out. I could delete them too, just to totally prove it, right? They're no longer there. But for some reason here, this still works, right? Because those methods exist in the vehicle class, as well as the variables, num doors, horsepower, current speed, not in the truck class. And one interesting thing that we're doing here in the constructor is see where it says super dot, super dot, super dot. Super just means I'm talking about something up in a parent class. And this dot means I'm talking about something in this class, right? So num doors, horsepower, and current speed, those are variables that are up in the super class, in the parent class. And so when I say super.numDoors, basically I'm saying I want to set that variable numDoors, the one that exists up here in the vehicle class. I want to set that to this variable numDoors that got passed in as a parameter to this constructor, right? Another interesting thing is that in the controller, you can also see up here at the top, we're saying T1.horsepower equal 300, T1.bed length equal 50, T1.current speed equals 0. Current speed, horsepower, num doors, those variables do not exist in the truck class. The only variables that exist in the truck class are bed length and has camper shell. Interestingly enough, though, we can use horsepower, current speed, and num doors, the variables that exist in the vehicle class, we can use them directly on that truck class as though they exist in that truck class, right? Because the truck class extends the vehicle class. So the same thing could be done here. Like let's start making some sedans. So I'm gonna say sedan S1 equals new sedan. And the sedan right now does not have any kind of constructor. I'll just say S1.trunk size, let's go with 35. And I can say S1.numDoors equals 4, S1.horsepower equals 150, S1.current speed, it's going on the freeway, let's say it's going 70, right? And then in my sedan, I'm also going to create this little toString method down here. I'm also going to update the toString method in this class because it's changed now that I've got it as a parent class. Now over here, I can say T1 dot, let's just go ahead and sout S1 dot toString. And so here we can see my sedan. It's got a trunk size of 35, num doors 4, horsepower 150, current speed 70. Keeping in mind that these three variables, they come from and are defined in the parent class vehicle, right? So we could keep going with this, right? Like we could do, let's do one more, because then we're going to talk about polymorphism real quick. So I'm going to create one more kind of vehicle. It's going to be a motorcycle. And I'm not even really worried about the way anything about a motor, like we could say like int cc or whatever, like the cubic inches of the engine or whatever. And then what I'm most interested here is let's start talking about polymorphism, right? Because on a sedan and a truck, the way that they accelerate is the same, right? You basically put your foot down on a gas pedal, right? And it starts to accelerate. But the way that you accelerate a motorcycle is slightly different, right? With a motorcycle, you're going to spin the throttle typically with your right hand, right? So they're both definitely vehicles, right? They just accelerate differently, right? But you want to be able to call the accelerate method on both of them, right? So the way that we'll do that, and I'm just going to focus on the accelerate method right here, is I'm going to override. So I should have this extend vehicle. I'm going to override the accelerate method. And instead of just saying vehicle accelerating, I'm going to say motorcycle, spinning throttle, right? Now back over here in our controller, I'm going to create a motorcycle. So I'm going to say motorcycle M1 equals new motorcycle. I'm going to say M1 dot num doors equals 0. M1 dot CC, let's go with like 1000, it's a big one. M1 dot horsepower seems a bit redundant. Current speed, let's say that it's going a nice leisurely 45. And now I want to accelerate it, right? And also just to, before we call M1 dot accelerate, I'm also going to do S1 dot accelerate, right? So I can call the accelerate method on this sedan, right? Even though the sedan does not have an accelerate method in it, the accelerate method exists in the vehicle class, right? Here it is in the vehicle class. And the sedan extends vehicle, which is why I can just do sedan S1, which is of type sedan, dot accelerate, right? That's going to call it's going to look in the sedan class for an accelerate method. It's not going to find it, but it's going to say, oh, this class extends vehicle. Does the vehicle class have an accelerate method? It does. So it's going to print out accelerating vehicle. Then in the motorcycle, when we create the motorcycle, we're going to use a lot of the same stuff, num doors, current speed that exists in vehicle, right? Because a motorcycle is a vehicle. And then when I call M1.accelerate, it's going to look in that motorcycle class for a method called accelerate, and it does find it. And this @override indicates that we are overriding the behavior of the accelerate method in the parent class. That when the accelerate method gets called on this type of object, specifically a motorcycle, instead of vehicle accelerating printing, in this case, it's just going to print out motorcycle. It's going to print out motorcycle spinning throttle. So let's just test that. Yeah. So we called accelerating vehicle was that S1.accelerate, and then when I said M1.accelerate, it was motorcycle spinning throttle. And this is polymorphism and abstraction, right? As far as the end user is concerned, we've got two different objects, right? They're both vehicle types. One's a sedan, one's a motorcycle, but there's this one method that we can call on both of them, the accelerate method, which is literally identical. The way that we use it is identical, right? Because they're both vehicles, they both have the ability to accelerate, they both should be able to accelerate. Therefore, on any object of any vehicle type, I should be able to call the accelerate method. But then behind the scenes, different things can happen based on the type of object that you're using that on, right? So for instance, a sedan, you push the gas pedal. A truck, you push the gas pedal. A tractor, you push the gas pedal. A motorcycle, you spin the throttle, right? And if I was going to create a plane or like a jet, I'm not even sure how you accelerate a jet, but you like maybe, push up the thrust or something like that. But still, I would be able to say jet.accelerate, tractor.accelerate, go-kart.accelerate, right? It's going to be this one method that has many forms behind the scenes, which is polymorphism and abstraction. So one of my favorite examples of polymorphism is system.out.println. So if you're getting familiar with Java, you're aware that Java is a strictly typed language, right? So like we have to declare the type of our variables. We have to declare in our methods, aka functions. We have to declare the type of data that method returns. We have to declare the type of data that method takes as an argument, right? It's all very strictly typed. So when I say sout and I pass the number 4, and then when I say sout and I pass the string 4, and then when I say sout and I pass the number 3.14, and then when I say sout and I pass my motorcycle, right? And I can keep going. When I say sout and I pass a single char, like the letter Z, these all work, right? So why does that work? This doesn't make any sense. This println method should not be able to take any different type of data that I'm passing it here. And so this is just printing out the actual object, like address ID. So, but you can see that it printed out 4, 4, 3.14, this object, and then Z. The reason that this is working is the counterpart to overriding, which is called overloading. It's also a primary driver of polymorphism in Java. So if we go down and look at this, and I call it drilling down, on my computer, it's I hold down the command key and I click on it. So go back to the controller. If I hold down the command key, this becomes a link. If I click on this, I'll drill down into the actual Java source code. And here we've got this println method, and you can see that this one takes an int. Here is another one, println method. This one takes a char. Here's another one. This one takes a Boolean. Here's another one. This one just takes nothing. Let's keep looking at some others. Here's another one that takes println that takes a long. Here's another one, println that takes a float. Here's a println that takes a double. I'm sure you're getting a picture here. Println that takes a char array. Println that takes a string. Println that takes an object. And I think that's the last of them. But what we've got there I can actually show you here is view tool windows structure. Over here in this little window that's popped up, you can see there's all of these, there's print and println. The only difference is that println will print whatever you're trying to print and then go to the next line, and print without the ln will stay on the same line, right? So here's all the printlns that we use so frequently. And you can see that that one method is defined 1, 2, 3, 4, 5, 6, 7, 8, 9 times. It's the same exact method with the same exact signature, public void println, but it has 9 different declarations, each one of them taking a different argument, right? So now we're up in the prints, but one takes a long, one takes a float, one takes an int, one takes an object, one takes a string. So from the front end, as far as the end user is concerned, it looks like a single method that we're calling, right? Println looks like a single method. It's not. It's actually 9 different methods, and the JVM will invoke the correct method based on the data that you pass it, such as the 4 or the string 4 or 3.14, M1 or Z, right? Those are 5 different data types. 5 different methods are being called behind the scenes there, which again is a perfect example of polymorphism and abstraction, because the details of what are happening behind the scenes are abstracted away from you, the end user. So the 2 primary big tenets of object-oriented programming are overriding, of polymorphism. The 2 primary kind of drivers of polymorphism are the idea that we can override something and overload something. So override is what we did here in the motorcycle class, where we said, look, I know I extend vehicle, and I know that there's a method up there in that vehicle class called accelerate, but I'm a motorcycle and I accelerate differently, right? We could also have a rocket ship, like a SpaceX crew capsule or whatever, or a Falcon 9 rocket. It also extends vehicle, and it's definitely going to have a different accelerate method than sedan, right? But they're both vehicles and they should both have that accelerate method. So the way that I can make a motorcycle accelerate in one way, a sedan accelerate in another, and a rocket accelerate in another is basically by overriding the default behavior in the parent class. So the default behavior is just to print out accelerating vehicle, but I can override that in the motorcycle class, and I can say when accelerate gets called on a motorcycle, actually I want you to call this method, overriding the behavior in the parent class. So that's overriding, where we're overriding something in the parent class. Overloading is when we write the same method more than once, same exact method signature, but the variables are different. The parameters, the arguments that this method takes are different. And the perfect example of that is system.out.println. That's a single method that's overloaded 9 times. So we always feel like we're just calling this one method. It makes it really easy and intuitive, but actually behind the scenes, it's much more complex than that. It's 9 methods, and the JVM will infer which one to call. So we could kind of keep going on this for a while, but I think this kind of covers encapsulation, right? The idea of a truck, everything that's related to a truck is in the truck class. But then we also have this idea of inheritance, where any attributes or variables, data that a truck shares with a sedan or any other vehicle, we'll actually put that up in the vehicle class, and we'll have the truck and the sedan and the motorcycle and the rocket extend this class. So this is where all of their, I don't know that a rocket is a vehicle, but this is just quick and fun. But this is the idea of inheritance, where we can have, I could have let's say a specific type of truck. Let's go with a, Dodge Ram. I could have a Dodge Ram class that extends truck, and the Dodge Ram class, all it has to do is define what makes it a Dodge Ram rather than a Chevy Silverado or something like that. And that inheritance hierarchy can keep going and going and going as deep as you want. And in the Java class libraries, you'll see it all over the place. This idea of extends this class, extends this class, extends this class. So we've talked about encapsulation. We've talked about inheritance here. And then we've talked about polymorphism with the idea of overriding and overloading. And I'm just going to leave you with, I know we're at time here. It's been, we're 3 minutes short of 1 hour. So I'm going to leave you with one last thing, which is this idea of an interface. And this is a bit confusing for people as we first get started, but I'm just going to create a quick interface so that you kind of know what I'm talking about. And it's because interfaces are the next kind of primary driver of polymorphism, and they're also just really useful. So vehicle interface, and an interface, if you're not already familiar, is a class. It's not a class, it's an interface. So we actually swap out the word class for interface. And in an interface, we create methods, method signatures, abstract methods. So we write the signature of methods, but we don't create the body. So let's say that, so I've already done start, stop, accelerate, decelerate, but basically what I would do here is that once we start getting into actually starting and stopping and accelerating and decelerating vehicles, that's very important, right? That each vehicle implements those methods specifically for their own class. Like when a jet is slowing down or stopping, it's going to be a whole lot different than when a go-kart is slowing down or stopping. And I don't want either of them to ever fall back on this default behavior here in the and let's just say like accelerating and decelerating. We'll just use these two. Let's say I don't ever want anyone to have the option to use this default behavior of accelerate and decelerate in the parent class. So I don't want gokart.accelerate to be able to hit this method, nor do I want fighterjet.accelerate to hit this method, because if that happens, something's gonna go wrong, right? Like there's gonna be a bug that fighterjet is gonna probably not accelerate or decelerate because the code that we've written in there basically typically accelerates some kind of car with a gas pedal or something like that. So I just don't want to mess with that at all, right? And I'm going to get those methods out of here. And what I'm going to do is I'm going to put those methods inside an interface. And what this does here is basically says, let's say that I'm the CTO or director of engineering, or even just a lead engineer, somebody at this company, and I basically tell/ask the engineering team, you know, anytime you're creating any type of vehicle, whether it be a rocket, a go-kart, you know, a fighter jet, or a lovely sedan, it must implement this vehicle interface, right? And so then what that means is, and you can do it at any level. I could have the vehicle interface right here. I could say implements vehicle interface. And immediately I have an error, because as soon as you implement an interface, you must declare the body of those abstract methods. These are called abstract methods. They're method signatures, but without a body. At the moment you have a class that implements an interface, you are required to implement those methods, right? So here, basically, it would be like implement methods. But now we're right back to where we started, where we're putting this accelerate and decelerate method in the vehicle class, which is not what I want. So I want each individual type of vehicle to implement those methods. So what I'm going to do is I'm going to call this an abstract class. So public abstract class vehicle implements vehicle interface. So what this means is that any class that implements, that extends vehicle in that inheritance hierarchy, it's now going to have that error, and it must, unless it declares itself abstract, it must implement these methods. So motorcycle already had accelerate. Let's just say slowing down. And you'll notice that my sedan also has to do that. And I just put these little system.out.print lines in there to show like something happening. Obviously, you would typically do more than just print something to the console. But this is just to demonstrate. My truck also is required to implement those methods, because my truck also extends vehicle. Vehicle implements that interface. And so what this is going to do is it's going to force any developer that's creating any type of vehicle, and obviously any type of vehicle that they create, they're going to have that extend the vehicle class. The moment they do that, they're going to have this error right here. Class truck must either be declared abstract or implement abstract method accelerate in vehicle interface. So here I can just say implement methods. I will not be able to compile my code or run my code until I implement these methods in this class. So truck accelerating. And now when we go back over to our controller, you'll notice that all of this stuff is still going to work: start, stop, accelerate, decelerate. But anytime it basically, yeah, it's just going to continue to work. But now instead of ever printing vehicle accelerating or vehicle decelerating, it's always going to be more specific, like sedan accelerating, motorcycle spinning throttle, truck accelerating, truck decelerating. And the idea of the interface, and I know I'm glossing over this quickly, but the idea of the interface is that this will require, it's a requirement, it's a rule. This is the vehicle interface. There's these two abstract methods, accelerate and decelerate. It's something that every single vehicle that this company ever creates must be able to do. I, as the programmer right now, I don't know how every single vehicle we're ever going to create is going to accelerate or decelerate. I really don't. Like, there's going to be, this code is going to be around for years and years. There's going to be go-karts and biplanes and rocket ships and, you know, cruise ships, if anybody ever gets back on them, and all these different types of vehicles, and they accelerate, decelerate in different ways. And I'm not in any way ready, prepared, or, you know, knowledgeable enough to know how to make each and every one of those things accelerate or decelerate. I just know that they must be able to accelerate and decelerate. It's a requirement, right? It cannot ever be a case where my rocket ship does not have the accelerate option, right? That it must be there. So what I can do is create an interface, which is like a contract, and then I can take this vehicle class, I can have it implement that interface. Since, again, the vehicle class, I don't know, there's going to be differences between the way a rocket ship accelerates and the way a go-kart accelerates, right? So in this vehicle class, we're not prepared to actually write the code necessary for the rocket and the go-kart in one method. That doesn't make any sense, right? So I'm going to declare this class abstract, and then any class that extends vehicle, such as motorcycle, will then be required to implement the accelerate and decelerate methods. And then that motorcycle, now in the motorcycle class, now I do know how to accelerate and decelerate. I accelerate by spinning the throttle. I decelerate by pulling the brake, right? If I was in the truck class, I accelerate by pushing the gas pedal. I decelerate by pushing the brake pedal. If I'm in the rocket ship class, you know, I accelerate by lighting the rocket engines, and I decelerate by you know, lowering my orbit and entering Earth's atmosphere and starting to get drag, right? When I get down to a low enough level, I actually do know what I need to do inside these methods. So again, from the end user's perspective, back over in the controller, here when we call, you know, accelerate and decelerate, what we're actually using here is we're using those methods were officially originally defined in an interface, right? So that's and then they got kind of trickled down to where we implemented them, and that's why and how interfaces are also a really big part of polymorphism, many forms, right? So I'm going to stop it there. Quick review. Let's go back over here to the slides. Object-oriented programming is a programming paradigm that organizes code around data, aka objects, rather than functions and procedures. So think about the way that we would create a truck class and create objects of that truck and set the truck's current horsepower and set the truck's current speed. And then we use that truck to do various things that we want. We could create a method that, you know, the parameter type in that method could be vehicle, and any class that extends vehicle, whether it be a motorcycle, a truck, a jet, or a go-kart, or whatever, could be satisfied as we could pass that into that method as that data type, right? And so we're working around these objects all the time. Encapsulation, all data and methods, aka functions that act on that data, are encapsulated within a class. So anything related to the jet is in the jet class. Anything related to the cat is in the cat class, right? The cat's color, the cat's claws, the cat's methods to meow and climb a tree, etc. All of that stuff related to a cat, it's inside the cat class always. That's encapsulation. Inheritance, the cat can inherit from animal. Cat extends animal. Dog extends animal, so all the things that a cat and dog share, all of its shared attributes are in that animal parent class, and the cat and dog have direct access to those variables and attributes and methods as though they are their own, right? There's abstraction and polymorphism. Again, I kind of hand wave and blend these two together, but polymorphism meaning many forms. And you know, like the system.out.println method, something we use all the time. It looks like one method, but it actually has 9 forms. And which one gets called behind the scenes, whether it's the one that takes a double that gets called or the one that takes a string that gets called, that's abstraction. The JVM will infer which one that we're trying to call there, right? And the 3 primary drivers of polymorphism would be overriding, so overriding the behavior of a parent method, such as the way we overrode the accelerate method. When we were inside the motorcycle class, we overrode the accelerate method in the vehicle class, because a motorcycle doesn't accelerate the same way that a motorcycle is a vehicle. We want it to extend vehicle. It makes sense in every form except for accelerate and decelerate, because a motorcycle accelerates by spinning the throttle and squeezing the brake, which is not what most other vehicles do. So we're going to override those methods in the motorcycle class. We can also overload, which is system.out.println is a perfect example of overloading to achieve polymorphism. And then we've got this idea of interfaces, which I like to think of as contracts, right? It basically ensures 100% of the time that the appropriate class will have the accelerate and decelerate method, and they will be implemented, because if they don't implement them, you actually won't even be able to run or compile your code until you do. And then I can be safe that the rocket is going to accelerate the way a rocket accelerates, and the go-kart is going to accelerate the go-kart the way a go-kart does. And neither of them are just going to use some generic like vehicle accelerating method in the vehicle class. So I know that's a lot there. Before I'm going to open up to a quick QA if any of you have any questions, but you know, just a shout out to our YouTube channel. We're slowly building it up. We're trying to get lots and lots of great material on there on a weekly basis. So check us out on YouTube, Coding Nomads. We've also got a really great online learning platform, platform.codingnomads.co. We've got courses in Java, Python, data science, web development with Python. We got a great one on the Spring Framework with Java coming out. We've got a JavaScript course. We've got APIs and databases. We've got SQL. We got lots of great stuff on there. You can create a free account. There's several of those courses are free. Even the ones that you have to pay for have a really extended free preview. It's quite great. So please feel free to check that out. Platform.codingnomads.co. And thank you for joining. So tomorrow, day 3, we're going to discuss, basically we're calling it acing the coding interview. with these custom data structures. So we're going to discuss the idea of data structures beyond the idea of an array, for instance. We're going to talk about linked lists, hash maps, queues, and stacks. We're going to talk a little bit about big O notation and algorithm complexity. And it's kind of, so first day was fundamentals, variables, data types, operators, arrays. Second day intermediate, principles of object-oriented programming. Third day a bit more advanced with the data structures and algorithms kind of stuff. So please enjoy the rest of your day. Thank you for joining.
Hey everyone, thanks for watching. If you enjoyed this video, please let us know by liking and subscribing. If there's another topic that you'd like to learn more about, leave us a comment. We would love to hear from you. And if you want to become a coding pro, visit our website at codingnomads.co. See you next time.